Hey guys, I am Matt Haskett, and I am now going to go over what I did for the AI in my level. In this video, I will be covering a brief rundown of the behavior tree, the unique things I did, how I accomplished them, why I made the decisions I made, and how I plan to implement new ideas into this moving forward. So starting out, I want to briefly go over the behavior tree and how it works. So this is the basis for how the AI will work in our horror level and adopts simple traits of enemy AI from games like Resident Evil and Outlast. So starting from left to right, the AI has a chase function that will give chase to the player when spotted with AI perception and attacks the player when they get close. The next branch is for when the AI can no longer see the player and goes into the search branch. This gets the player's last seen location and creates random vectors around the point that the AI will move to. After it searches 4 times with the search index, it will resume its patrol path, which, speaking of, we have here. Now the patrol path is simple. It makes the AI go to 4 separate patrol points around the map until it spots the player. Now how does this relate to the unique thing I did for the project? Well, the unique thing I did is specific for the chase function. So moving into it, what I did was I created a selector node that randomly selects query filters to create a more dynamic AI. So what it does is it uses modifier meshes in the level that have their mesh values mesh values manipulated with query filters. So for instance, if it randomly selects query filter 1 while the AI is chasing, it's going to override the blue path, giving it a higher value, and the AI will not want to take this path, and it's going to instead choose the red path towards the player. Or if it instead randomly selects filter 2, it's going to override the red path instead with the higher value, and it's going to want to take the blue path around the wall instead. I decided to do this when the AI is chasing because it'll be more unpredictable when getting chased. So for instance, depending on the situation, the filter chosen, and the modifier meshes in the path of the AI, it's going to either make a beeline straight to the player, or it's going to try to go through a side path to cut the player off. Now, how I did this was I created a local variable for the filter class, and using a select node that accepts filter classes as options to switch between them. It then uses a random integer in range for the index to randomly select a query filter to use every time the player gets spotted. Alternatively, I could have done this for the patrol points as well by iterating each item in the array, then setting that patrol point as the target, which will turn on the query filters, and it'll theoretically make the AI take different paths while on patrol. I decided not to do this for the patrol points as sort of like an alternative win con. An alternative way for the player to win is they can learn the patrol path of the AI and try to make educated decisions about sneaking around their path. So with this, they could theoretically win without running into the monster as long as they take time to learn the monster's behavior. I'm still 50-50 on this specific decision, so please let me know if it would be better to make the patrol path more dynamic and unpredictable, similar to the chase function as well. Moving forward, I would like to expand on this system by using an inventory query system so that the AI can get information about the environment and perform actions with models in the environment, or by getting instances of an object and checking each instance. So things like checking lockers when looking for the player. That is all I have, so thank you very much for watching, and have a good day.